Hello and welcome. My name is Brett Schuhart and this continues the RPN calculator series. This time I'm adding another operator. It'll be a prime factors. So it'll take the top value off the stack, whatever that value is, it'll calculate the prime numbers that multiplied together equal that result and put them back on the stack. So for example, the prime factors of 6 are 2 and 3. The prime factors of 12 are 2, 2, and 3. And then the prime factors of 1024 would be 10 twos. 10 twos on the stack, 2, 2, 3 on the stack, etc. And I'm not going to put a constraint on whether the lower numbers or higher numbers should be there first. So let's go ahead and get started. I'll verify that for the project the tests are still running. And looks like, sure enough, they are. Great. So now that I know my tests are all passing, I can start with a new test. So let's go ahead and add a new test. Now for this particular test, I'm going to sort of play around with the style a little bit. And I'm going to make it look quite a bit different than the other tests you've seen before. So how's about, we'll start with 1. The prime factors of 1 should be an empty stack. So prime factors test of 1 should give empty stack. There we go. I think that's a well-named test. So how's about given a value of 1, when calculating its prime factors, then the result should be empty. Alright, so there's my test. Now it's a bit weird. I'm just sort of writing it, but I'm going to add in these methods. I'm going to stub them all out. Alright, so there we go. These are just going to be plain old regular methods, but what the heck are they going to do? Okay, so given a value of whatever, what I'll do there is I'll say new big decimal of the value provided. And I'm going to assign that to a field. Alright, that's all it's going to do. When calculating this prime factor, so operand stack push the value onto the stack, and then I'm actually going to say, go ahead and do it. New prime factors dot execute on the stack. This is fine except that, well, there's a couple problems. Let's go ahead and create this class. I'm going to create the prime factors. It will be a math operator, sure enough. Alright. Save that, close it out. And I want to make sure that this stack is remembered because I'm going to use it in the next method to verify it. So let's convert this to a field. Alright. And then finally, then the result should be empty. So I guess that's easy enough. Assert equals 0, comma, stack dot size. Handy that I've already added that in as a result of the previous operator, eh? No, I didn't want to do that. This is an interesting little glitch with Eclipse. I'm going to put this temporarily up in an actual test method. Then when I hit Control 1, it'll find it for the static insert, static import. There we go. And then I can put it back down there again. Okay, so I've got the test. Given a value of 1 when calculating its prime factors, then the result should be empty. I'm going to run the test. The test is going to fail. Sure enough, the test does fail. So now what I'm going to do is I'm going to go ahead and get this test passing, as always. That should cause the test to pass. Excellent. In fact, all the tests are running and they all pass. Great. Alright, so let's go back here and take a look at the next test. Given a value of 2 now, when calculating prime factors, then the result should include 2. I'll have to create that method. Then the result should be empty. Alright, I'll leave that for now. I'm not going to rename that yet. Okay, then the result should include 2. So what that's going to do is it's going to verify that and I'm going to also go ahead and remove that value. Once I've verified that it's there, I'm going to remove it. Alright, so let's go ahead and run that test. It'll fail. I expected 2, but it was 0 because the stack is actually empty. So now, let's go here and do something with this. I guess I'll assign this to a local variable. I guess if value compare to and if it's equal 0, so if it's 2, then values.push value. Alright, now I've got to organize my imports, save that. Values, okay. This is values.peak, and then values.pop. There we go, let's see what that works. Okay, looks good. So now what I'm going to do is I'm going to do just a touch of cleanup. I'm going to say this is a constant. I'm going to go ahead and make that a constant. To a constant, and we're going to call that 2. Excellent. Alright, run the test. Should still work. And looks like it's fine. Excellent. So now, let's go ahead and next test. Okay, so I'm thinking I'm going to go ahead and do 3, and then I'm going to work maybe to 4, but then 5 is going to be similar to 3. I'm sort of thinking ahead. Not all the numbers represent different equivalence classes, but for right now, 3 is different from 2 because I'm sure it'll work. It'll fail. Alright, so given a value of 3, when calculating, it should include 2 and should be empty. Okay, cool. So I'm going to run this. I expected 3, but it was nothing because 3 did not get put on. Well, that should be easy enough. I can change this from equals to greater than or equals to. That's how the compare to function works, I believe. Okay, 3 works. Lovely. All right, let's go to 4. So of 4 should be 2 and 2. All right. Include 2 and 2, and then the result should be empty. All right, let's go ahead and make that method. And that's just going to be a synonym for then the result should include I. Save that. Okay, and also I'm gonna go ahead and, this method is bothering me, but I'm gonna rename it after I get this test passing. So first of all, run the test. I expected 2, but it was 4. Okay, great. So let's see. If it's greater than 2, then I want to push the value. Well, now 2 divides into 4, so I want to push 2 onto the stack instead of putting 4. So if I guess if value dot remainder, remainder of big decimal 2, so 2 is equal to big, no, dot equals. I'm working with big decimal 0. So if it's, this is the same as modulo, but it's the version of modulo for big math, then I want to values dot push 2. And I guess also, since I put 2 in, value equals value dot divide divisor. What is divisor doing there? Oh, that's the name of that default parameter, 2. I put in a 2, so I'll take out a 2. And then I'll push the remainder. Okay, let's see if this works. And well, of course, it might help if it compiles. Okay, oh, I broke 1. Expected 0, but it was 1. Oh, boy. Oh, here, I think I can just put this whole thing in a big old block. That was my mistake. Alright, expected 2. Boy, I'm just breaking everything, but was 1. Alright, that did not fix it. So what I'm going to do is, I guess, if value compare to, this is ugly, but it'll get uglier before I make it nice. Compare to 2, if it's greater than or equal to 0, then I'll push the result on. There we go. It's ugly, there's some duplication, but that's fine. I'm working my way through it. Sometimes you have to get enough ugliness to see patterns emerge. Okay, let's go back to the tests here. I have the wrong name. That should be 4. Test should still be fine. And I'm going to go ahead and rename this method because most of the time it's after a check of a value, so I don't like that name. I think that's it. I'm just going to change it from that to that. So given a value of 4, when calculating its prime factors, then the result should include 2, and the result should be empty. Alright, I like that. That's better. It makes one test look a little bit funky. Given a value of 1, when calculating its prime factors, and the result should be empty. Okay, I'm going to ignore that for right now. Let's continue on with the main thing we're trying to get to. I think this is going to work right away, but let's just verify. So 5 should include 5, and then the result should be empty. Let's see what happens with this one. Okay, great, it works. I think 6 is a difference equivalence class, though. Now, I'm calculating these values, and I'm sort of getting the lower values first and the higher values last, so the higher values are going to be on the stack. So I'm going to go ahead, should be 3 and 2. This is the way I'm going. I can see that. So let's see, given the value of 6, then when I calculate its prime factors, you should include 3. That didn't help me at all. And 2, and then the result should be empty. Alright, now this is going to fail like, whoa, it worked. Okay, well, bit of a surprise there. 5 worked, so 7 worked, so let's try 8. I'm assuming 7 is going to work because 7 is a prime value. But 8 has 3 as opposed to 2 values in it. So given a value of 8, when calculating its prime factors, then the result should include 2, and 2, and 2, and then the result should be empty. Let's see if this works. Alright, expected 2, but it was 0, but it was 4. Okay, so it only divided once. Okay, so how's about this? Instead of an if, let's change that to a while. Excellent. Solve that problem. Okay, let's see. Let's go to 9. 9 is different because instead of always dividing by 2, it's 3 and 3. So that should probably fail. Alright, so given a value of 9, when calculating its prime values, then the result should include 3 and 3, and then should be empty. Alright, I think this is going to fail. Expected 3, but it was 9. Why? Because 9 is not divisible by 2. So I don't want to just compare with 2. Okay, how's about this? Big decimal equals 2. So I'm going to do something crazy here. Let's see. So let's see. If the value is greater than the divisor, then I'm going to do this. I think instead of if I need a while here. Let's see if this does something. Whew, that worked. Excellent. Okay, now question. Do I still need to do this? I don't know. Excellent. So I started at 2. The value compared to that is equal to 0. So if it's greater than 2, then I'm going to go ahead and take out all the 2's. I'm going to divide all the 2's and take them out. Then I'm going to go to 3. And if the value is greater than 3, then I'm going to take out all the 3's. I'll take out all the 4's, but there won't be any 4's because I took out the 2's. Then I'll take out the 5's and the 6's and so on. So basically, I'm going to add 1 to divisor, working my way up as I divide value down. So I think this is actually done. Yeah, I think we're done. Let's do one more sort of bigger test, and then I think this is done. I'm sure I'll get comments on the video if I'm missing something. But how's about 1024 should be 10 2's? Alright, so I'll try that one. So given a value of 1024, and when calculating its prime factors, then the result should include 2, I guess. And 9 more 2's. This is a bit weird. Let's see if that works. So that's 10 2's. Excellent. Okay, great. Got the prime factor written. Do a quick recap. Let's see. I take the value, I remove it, and then I start by dividing by 2 and work my way up until I finally get all the prime factors. Great. Let's actually register it now in the calculator. So I'm going to go find that registry, and let's go ahead and create a new test for this guy. I'm going to run this test. It should fail. Excellent. No such operator. So now I'm going to go to the factory, and I'm going to add prime factors. Run the tests. All the tests pass. We're good to go. So now we've got prime factors, sum, factorial, multiplication, division, addition, and subtraction. We've got a pretty complete calculator already. Next time we're going to actually look at composing operators. Hope you enjoyed the video.